Hey everyone, what's up? Welcome back to Subnet Zero. So in the previous video, we had learned all about switch and its utility, its scalability, as in a network, if there are more devices getting connected in the same network, how switch makes it easier to connect to all of them, how it works, Ethernet ports and switch, MAC address table, what flooding is, what forwarding is, and what happens when a cable is disconnected from a switch, okay? Today we are going to learn all about VLAN. But before that, let's look at the types of network that exists, okay? So first is personal area network. Just remember this AN that you see over here, right? AN, that is area network, okay? So all of them, when you see AN, they're all area network, okay? Across the board. So first is personal area network. What does that contain? So imagine if you have your phone, okay, your cell phone, then you activate Bluetooth, and then if you have a headset associated with it, yeah, this is what we call a personal area network. Very simple. We pretty much use that on an everyday basis. Then there is a local area network. Yeah, so imagine like a small office or even your small home, okay? Imagine there is a PC, then there is a printer, and there is a cell phone, okay? And few other devices, but it is within your local network. That is a local area network, okay? It can be a small office, it can be your own home. Then there's wireless local network. So essentially, it's pretty much similar to what this is. Only difference is we'll use Wi-Fi over here. Only difference is we will use Wi-Fi over here, and over here, this is wired. Make sense? Then there is MAN, that is Metropolitan Area Network. Essentially, think of it like a city. London will have its own network. Mumbai will have its own network. New York City will have its own network. So essentially, that is a metropolitan area network. And there is wide area network. By wide area network, I mean, we are talking about countries, like on a massive scale. Countries like, think US, Canada, India, China, Russia. So these are we are talking like a massive scale, okay? Sometimes even multiple countries combined. So the scale is huge. So now that we have understood types of network, let's focus on VLAN, that's virtual LAN, okay? So let's say in this section of LAN, okay? Let me go down and VLAN. Now, what is virtual LAN and what is its utility, okay? So for example, let's say there is this one network which is associated with IT, okay? So imagine there is this one network which is only dedicated to IT in a company, okay? Then there is a second network which is only related to HR. Then there is a third network which is only related to sales, okay? So to ensure that there is a boundary between all these three, there should be no overlap, okay? So we will need a switch, okay? Switch for IT, switch for HR, and switch for sales, okay? But let's say if you do not want to have so many switches, if you do not want to spend as much money and you want to make it a lot more efficient, let's say if we just remove these three switches and instead only keep one switch, and that switch can ensure that sales is separate network, HR is separate network, and IT separate network without having and ensuring the same boundaries are maintained without any overlap between in either of these three departments. It can be more departments, but over here we're just taking the example of three departments over here, okay? So to ensure this boundary is retained, this is where virtual LAN is created, okay? So this will be one separate network, this will be one separate network, and this will be one separate network, okay? So the configuration in a switch to ensure that, these like a single network is divided into multiple smaller networks so that there is no overlap between either of them. That is what we call as VLAN or virtual LAN. Make sense? So this is essentially to ensure we do not have to purchase more switches, and one switch itself can do the job of multiple switches over here, okay? So now that we have understood what a VLAN is, let's look at what VLAN ID is, okay? So let's say if this is VLAN 10, this is VLAN 20, this is VLAN 30. So essentially, we are just naming it, okay? So for example, the entire IT department over here is VLAN 10. Entire HR department will be VLAN 20. Entire sales will be VLAN 30. So essentially, it's like naming the department, okay? Now, why VLAN 10, VLAN 20, and VLAN 30? Why not VLAN 1, 2, 3? So it is basically a tradition, okay? It's like an industry standard, a tradition that has always been used, okay? So this is what we call as VLAN ID, essentially an identification for each department with VLAN 10, VLAN 20, and VLAN 30, okay? The switch that you see over here, this is a VLAN switch. Again, when you talk about access port, we're always referring to a switch which has a VLAN, okay? Which is configured as a VLAN, okay? So let's say if this PC over here, let's call it PC1, okay? If PC1, this one, it's connected to the switch using an Ethernet cable, okay? So once this Ethernet cable gets connected to the switch over here, let me show you what it looks like, okay? This port, suppose over here 1, if it's connected to the first port over here, okay? That acts as an access port. Make sense? Similarly, if PC2 over here, okay? If this is connected using a copper or fiber optic cable in the second port over here of the VLAN switch, okay? Over here, second. You see over here, second. This acts as an access port, okay? The port that you see over here, similar to say. So this is what essentially an access port is. Ports, okay? Now let's explore what trunk ports are, okay? First, let me clear up this board. This is going to be a little complex, so please pay attention, okay? So let's say if we have computer 1, computer 2, computer 3, okay? It is what we call as VLAN 10. Similarly, we have another network. Let's call this VLAN 20, okay? And now let's say we have 2 switches. I'm using this diagram to represent switches, okay? Let me just ensure it's formatted properly. Yeah. Let me do one thing. Let me use only 2 PCs to make you understand what VLAN trunks are, okay? To ensure there is no confusion. Okay. This one is PC1. This one is PC2. This one is PC3. And this one is PC4. Okay. So let's say, let me call this switch A and switch B. And again, both switch A and switch B are VLANs, okay? Let's say switch A wants to connect to PC1 and switch A also wants to connect to PC2 in VLAN 20, okay? And this is in VLAN 10. Simultaneously, I'll use this one, yeah. In switch B, again, another VLAN switch. If switch B wants to connect to PC3 and PC4, okay? So here we have this weird situation where switch number A, again, both the VLAN switches, switch A wants to connect with one computer in like one network and another computer of another network. And same is the case with B. Now, how would trunk ports work in such a scenario? Okay, so let's take a couple of scenarios when it comes to PC1, and you'll understand the flow. Okay, so first, can PC1 talk to PC2? Nope. Completely blocked, because again, both these VLANs don't talk to each other. Can PC1 talk to PC4? Nope. Also blocked. Different VLANs. So the only scenario over here that we can find it feasible is that PC1 talks to PC3. Okay? But how? Now here's the whole trunk ports. It becomes as a massive utility tool. Okay? So let me show you what I mean by that. Okay? First, PC1 will send a packet to switch A, okay? Switch A will understand that it is is it in VLAN 10, but it is not configured to provide this to PC3. PC1 will send data to switch A. Okay, again, this is switch A, switch B, okay? And it is addressing to PC3, okay? So switch A will be like, hey, I know it is directed to PC3, it is in VLAN 10, but I do not handle PC3, okay? So what it will do is that it has to communicate to PCB. It has to communicate to switch B, okay? But here's the thing, how will it communicate to switch B? Because switch B handles PC3, right? So here's where trunk ports come in, okay? So essentially, switch A and switch B will be connected to each other through a the Ethernet cable, okay? It can be either copper or fiber. It will look like a normal, like a regular Ethernet cable, but it serves a very different purpose, okay? So what it will do is that once connected, switch A will realize, oh yes, since switch B handles PC3, let me redirect the packet to switch B. So first it will go to A will redirect it to B through this Ethernet cable, and switch B will then redirect it to PC3. Make sense? So this part, what we are looking at, this part is what we call a trunk port, okay? Again, trunk ports, normally we use it in such scenario. I hope this diagram is useful. This diagram clarified it all. And for further getting into detail, let's understand VLAN tagging, okay? So you can see real time how the communication works with proper tagging. Over here. Yeah. So I want all of you to get familiarized first with this, something called as 802.1Q. Now, what is that, okay? Now, 802.1Q is like a set of agreed upon industry standards. For example, let's say I'm pretty sure all of you have at least visited the airport at least once, right? Or let's say a shopping mall, okay? So let's say every item or every luggage of yours, the staff will, add a tag to it, yeah? Same barcode, same tagging, and it will be in a certain format, okay, certain agreed upon format. So that standard, the agreed upon format, is what we call as 801.Q. It's more related to compliance, okay? So as per 802.1Q standards, there is something called as VLAN tagging. Again, this is very different from VLAN ID, okay? Please do not get confused. VLAN tag is a very different concept, while VLAN ID is about VLAN 10, VLAN 20, VLAN 30 is the identification of different VLANs, okay? So let's explore what VLAN tag is all about, okay? So yeah, you see the Ethernet frame over here that we did in our previous videos. The data is first converted into binary that has been boxed into a payload. Payload has the destination IP address and the from IP address, the source IP address, okay? And it's also further boxed into the Ethernet frame, which has the destination MAC address and the source MAC address, along with the frame check sequence, okay? So over here, the tag, VLAN tag. Let me just write it over here. Yeah. So this is essentially VLAN tagging, the one you see this pink box over here. Now, what role does it play? Let's explore, okay? So from PC1 to switch A, okay? First, this will be untagged. Why untagged? Because there is no special need to explain that this is VLAN 10, because while going, it's already going to switch A, okay? Which is why it doesn't need any particular tagging. Now, here comes the interesting part. Switch A will need to communicate to switch B that it is in the same VLAN. So here the tagging comes. So this will be VLAN 10, okay? Essentially, switch A is telling switch B that, hey, this is of my network, but you have been configured to take care of this PC3, okay? So now, after the VLAN tag is added, it gets transferred to switch B, and the switch B then routes it to PC3. And while the routing is going on, the last step will be PC3 from switch B, VLAN 10. This will be PC3, and this will be switch B. This will be the last stretch. Yeah, so this will be from switch B MAC address to PC3 MAC address, and from this will be to PC3 MAC address from switch B, similarly to PC3 IP from switch B, okay? And this will be VLAN 10. This will be the last stretch, how the Ethernet frame will be converted to that. So there's a lot of changes going on in this entire the circulation. So based on whichever hop it is in, okay? So if it is from PC1 to switch A, it will remain untagged. If it's from switch A to switch B, here's where VLAN 10 comes in, okay? But if it's from switch B to PC3, then this VLAN gets back to untagged. Make sense? So again, this tag only works if we are if there's a trunk involved. When there's no trunk involved, it gets untagged. Make sense? So this is where VLAN tag comes in. Again, please do not get confused between VLAN tag and VLAN ID. In VLAN ID, we are naming the different VLAN networks like VLAN 10, VLAN 20, VLAN 30, while VLAN tag is only between this trunks and is to ensure there's communication going on between different switches for the same VLAN. Make sense? Again, to ensure it's fully clarified, okay, let's divide it into three phases, okay? This is phase 1, that is from PC1 to switch A. Then switch A to switch B is phase 2. Then switch B to PC3 is phase 3. So how will it look like, okay? In phase 1, it will be to switch A. By now, I'm sure all of you will know that, in the Ethernet frame, this means from MAC address and this means from IP address, okay? So this will be phase 1. It will remain untagged, okay? To switch A MAC address to switch A IP address from PC1 IP address from PC1 MAC address, okay? Untagged. This concludes phase 1. Now let's go to phase 2, okay? So this is the second phase where the trunk is involved, okay? That is the Ethernet frame getting transferred from switch A to switch B, okay? So this will be to switch B, MAC address, switch B, IP address, from switch A, IP address, from switch A, MAC address. Here the VLAN 10 tag will be added, okay? This is the second phase. Again, I conclude, this is the second phase. Now let's explore phase 3. Okay, so here, now this is phase 3 is where it is from switch B, the third phase over here. You see over here from switch B to PC3. So it's from switch B to PC3 IP and PC3 MAC. And here the VLAN tag over here is untagged, okay? And again, for proper demonstration, this VLAN tag is added after the payload and in the Ethernet frame, okay? Make sense? So this concludes phase 3. Yeah, makes sense? I hope there should be no confusion now. So now that we have covered this, let's cover native LAN. Now what is that? Okay, let me just clear up this board first. This is relevant, okay? Yeah, so now when it comes to native VLAN, okay, what that is. So, the VLAN tagging that we have during every, in this trunk that you see over here. So, in Ethernet frame, whenever it's passing like through a different switch for the same VLAN, we usually use a trunk over here, yeah? The trunk that we use over here, which always includes a VLAN tag. So, there are exceptions in which this is completely like, there's no tag over here at all. Let me just remove this. Yeah. So there are like certain exceptions where this entire tag itself is missing. In this, during this transaction between these two VLAN switches, okay, the entire tag is missing. Now, again, let me clarify. That is an exception, okay? When does that happen? That happens usually like, old or non-configured, like some really old devices which does not follow the 802.1q standards. Or let's say, some really old systems or some really legacy systems. And again, most of you, this is a rarity. Okay, again, let me tell you, this circumstance is a rarity because like such old devices or the devices that does not follow 802.1q compatible, they are rather rare. But you should know that this concept exists, okay? So in such case, such tags do not exist at all. So this is what we call a native VLAN. That is inter-VLAN communication. Yeah, let me first clear up this board because this is because this requires multiple hoops, okay? Let me just remove this, yeah. So what is basically inter-VLAN communication? In inter-VLAN communication is so that multiple VLANs can connect to each other. Now you'll be surprised that, because we had learned in this that, both the VLANs never connect, right? Because they're always blocked. Now, if you're only looking at VLAN as a concept, yes, it is. But we can still find a way to connect both the VLANs, the PCs from VLAN 10 and the PCs from VLAN 20. How? Using a router. And if you or some of you remember in my first playlist, that is, how router helps in connecting multiple networks. This is exactly the form that it takes over here as well, okay? So essentially what router does is connect multiple closed networks. So this router, once placed, will ensure that both the VLANs can connect with each other. How will it work? Let me show you, okay? So first, let's take PC1 as an example, where first it wants to connect to PC3, PC2, PC4. How will the hoops work? Okay, how will the hoops look like? Okay. So first, let's take the combination of PC1 and PC4. Okay. So PC1 will send data to switch A. Switch A will send the data to router. Router will again send it back to switch A. Switch A will then transfer it to switch B. Then switch B will transfer it to PC4. Okay, this is scenario 1. This is how it goes. Oh yeah, one more thing I just forgot to add. The router is only connected with switch A. That's why the packets first go to the router and return back to switch A. And from there, it gets transferred to switch B. Make sense? Again, let me clarify. This router is only connected to switch A. It has nothing to do with switch B. Okay? So which is why you will see from PC1 to switch A, then it goes to the router. Again, it comes back to switch A because it's only connected with switch A. Okay? Then it gets transferred to switch B and then PC4. Okay? This is scenario 1. Now let's look at the second scenario where computer 1 wants to connect to computer 2. Let me use a different color. Let me use the steel color. Yeah. So first, computer 1 will... Actually, let me use a different color. Yeah, let me use this lavender color. So computer 1 will send its packets to switch A. Switch A will send its packets to the router. Router will return it back to switch A. It will directly go to PC2. Why? Because in switch A, PC1 and PC2 are directly connected with an Ethernet cable. Now, if you do not have a router, any computer from VLAN 10 and VLAN 20, they will never interact. But since there's a router involved, this ensures connectivity between both of them. So it will be from PC1 to switch A to router, router back to switch A. Again, why switch A? Because the router is connected with switch A. And again, from here directly to PC2, because both are connected to the same switch via the Ethernet cable. Okay? This is scenario number 2. Now let's look at scenario number 3, where, we want, let me use the color green, where we want to connect PC1 and PC3. So PC1 first will go to switch A. And since this is the same VLAN, we do not need a router here. Switch A will go to switch B, and switch B will directly route it through PC3. Make sense? So I hope this diagram and this flow and me using different colors clarifies the flow of Ethernet cables, how it goes, how it flows between different VLANs, and when there is different switch involved and there is a router involved. Fairly complex, but please go through this once again. You'll understand what I mean. Again, let me repeat to ensure that it's absolutely tattooed inside your brain, okay? Let me first clear this board. Yeah, I'll repeat the whole process once again so that if there's any confusion remaining, it's all cleared up, okay? So first, I will use the color blue. The scenario is in VLAN 10, there is computer 1 and computer 3. In VLAN 20, there is computer 2 and computer 4. In switch A, using the Ethernet cable, it's connected to PC1 and PC2. In switch B, using the Ethernet cable, it's connected with PC3 and PC4. And switch A is connected with the router, only and only switch A. Now how the information flows, okay? From PC1 to scenario number 1, PC1 to PC4, then PC1 to PC2, then PC1 to PC3. Make sense? So let's go. Ethernet frame from PC1 will go to switch A. From switch A, it will go to the router. From router, it will come back to switch A. And from switch A, it will go to switch B. And from switch B, it will go to PC4. This is scenario number 1. Okay, I'm sure now it will make sense why. Scenario number 2 is between PC1 and PC2. Okay, so it will be PC1 to switch A to the router, router back to switch A, and from switch A, directly it will go to PC2. Make sense? Because again, there is no need to go through any hoops because PC2 is directly connected through an Ethernet cable in switch A. Okay? Scenario number 3. PC1 to switch A, from switch A to switch B, and from switch B to PC3. Make sense? Again, in here, we don't have, in this third scenario, we don't have to go through the router because it is in the same VLAN. Make sense? So yeah, I hope these drawings and diagrams with these different color coded has made it really simple for you to understand. And if you find this useful, please like and subscribe. Please hit the bell. Share it with someone who might find this useful. And in future videos, we are only going to get deep into the rabbit hole, okay? So we're going to have a lot of fun, I promise you. And thank you for watching. I'll see you in the next one. Bye.